Yeah. The Cavendish experiment, performed in 1797 to 1798 by British scientist Henry Cavendish, was alleged to be the first experiment to measure the force of gravity between masses in the laboratory. The results of the experiment were used to determine the masses of the Earth and celestial bodies. The Cavendish experiment is often held up as evidence for the universal attraction of mass and as a proof for gravity. The experiment involves two spherical lead balls attached to a torsion balance, which is alleged to detect the faint gravitational attraction between the masses. When institutions have reproduced this experiment with modern methods involving lasers and instruments of the highest precision, however, the detection of gravity has been fraught with difficulty, giving erratic results. Oddly, modern repetitions of the Cavendish experiment tell us that the readings deviate over tenfold from their expected uncertainties when observed at different times. It is admitted that the experiment is dominated by effects which are not gravity. The use of this experiment as a demonstration of the universal attraction of mass is further faulted at its premise. This experiment is a matter of observation and interpretation. In this experiment, a slight attraction with the force equivalent of the weight of a few cells is observed, and conclusions are then made about the strength of gravity for the entire universe. Those observations are used to estimate the masses of the celestial bodies rather than using the theory of gravity and the size of the Earth to determine the amount of attraction which should have been seen in the experiment. It is assumed that the attraction seen must originate from the universal attraction of mass rather than any other cause, which could cause attraction with the weight of a few cells at close range. Different values seen in the experiment would produce different conclusions for the masses of the Earth and celestial bodies.